Let's start by looking over the sampling distribution that we were working with last time. We had a sample of 5 people, and their ages were 20, 22, 24, 26, and 28. I wrote out all possible samples of 3 people, and there were 10 possible samples. I calculated the mean of each of the 10 possible samples, and when I put the 10 sample means in a histogram, the histogram looked like this. So right here we have the population mean of 24. This was the mean of all 5 people in the population, because when you add those 5 people's ages and you divide the total by 5, you get 24. Because the 5 ages were 20, 22, 24, 26, and 28. When you add those 5 numbers and divide the total by 5, you get 24. So 24 was our population mean. And we also found the margin of error. We found the 60% margin of error and the 80% margin of error. Let's start by looking at the 80% margin of error. The 80% margin of error was the distance from the population mean of 24 to the boundaries of the middle 80% of the possible samples. And we found out that 80% of the possible samples were between sample 2 right here and sample 9 right here. So this was right here, this was one boundary point of the middle 80%. This was the lower boundary of the middle 80%. This right here was the upper boundary of the middle 80%. So the lower boundary of the middle 80% was 22.67, and the upper boundary of the middle 80% was 25.33. So 22.67 and 25.33. So 80% of the possible samples were between those two numbers. So this is 22.67, and the other one is 23.33. And the distance from the population mean of 24 to each of these boundaries was 1.33. So 1.33 was the 80% margin of error. Now what about the 60% margin of error? Well, first I'll mark off the fact that this is the middle 80%. Let me think of the best way to do this. Well, maybe down here I'll just put 80%. So we just know that 80% of the possible samples were between these two numbers. Now, let's look at the boundary points of the middle 60%. The 6 middle samples were these 6 right here. So 6 out of 10 is 60%. So these 6 samples in the middle would be the middle 60% of all 10 samples. So all of the, the middle 60% of the samples are between this point right here and this point right here. This is 23.33, and this is 24.67. So the middle 60% of the possible samples were between 23.33 and 24.67. And I said that the 60% margin of error was just the distance from the population mean of 24 to these two boundary points of the middle 60%. And this distance right here and here were both 0.67. Sorry if this is small, but these two numbers both say 0.67. Just like how these two numbers up here both say 1.33. And I'll put 60% right here because this is the middle 60% of the possible samples. 60% of the samples are between these two numbers right here. We also talked about the confidence coefficients. I can label those on here also. This is still saying that the population mean is 24 up here. So the confidence coefficient was the z-score at the upper boundary of the middle area of the possible samples. So this right here would be the confidence coefficient for the middle 80%. It was z equals 0.81. So the z-score at the upper boundary of the middle 80% of the possible samples right here was 0.81. We found that out in the last video. And we also found out that the z-score at the upper boundary of the middle 60%, which is right here, was a z-score of 0.41. And in the last video, we used these z-scores to actually calculate the margin of error using a formula. And now, next I wanted to talk about how if the possible samples follow a normal distribution, then it's actually possible to look up these confidence coefficients in a table. The possible samples in this histogram don't really follow a normal distribution because it's, you can see how it's flattened out right here. But if the possible samples did follow a normal distribution, then the confidence coefficients would actually be predictable, and you could actually look them up in a table called a z-table. And I'll actually show you what those confidence coefficients would be when you have a sampling distribution that follows a normal distribution. So let's imagine now that instead of having this shape right here, instead of having this shape, let's imagine that our sampling distribution follows this shape. Meaning, let's pretend that it follows a normal distribution. This isn't a very good drawing of a normal distribution, but we'll pretend that this is a good drawing of a normal distribution. So maybe I could try it one more time. Maybe it's a little bit better. I'm not sure. I tried to make these two sides look the same, but it didn't come out quite the way I wanted it to. It's maybe a little bit better. But if the possible samples follow a normal distribution, then 80% of the possible samples will fall between these 2 points right here that I'll show you. %80 of the possible samples will fall between z equals point, let me see. I actually need to go to a website to find out what the z-score is.